The National Electrical Code, or NEC, mandates specific requirements for electrical installations to ensure safety and prevent hazards. Regarding garage wiring, a common question arises about the necessity of installing a subpanel. If there are more than 2 circuits running to the garage, the NEC typically requires the installation of a subpanel. The primary reason for this requirement is to provide adequate circuit protection. Each electrical circuit must be protected by a circuit breaker or fuse. The NEC limits the number of circuits that can be connected to a single circuit breaker or fuse, generally to a maximum of 2. When a garage has more than 2 circuits, a subpanel becomes necessary to accommodate the additional circuit breakers or fuses needed to protect each circuit individually. The subpanel acts as a distribution point for the electrical power, branching out the main electrical supply into multiple circuits. Firstly, a subpanel provides individual circuit protection. Each circuit originating from the subpanel has its own dedicated circuit breaker. This ensures that in the event of a fault, such as a short circuit or overload, only the affected circuit is tripped, leaving the other circuits operational. This is crucial for safety and convenience. Secondly, a subpanel allows for easier circuit management and expansion. As the electrical needs of a garage evolve, additional circuits may be required for new appliances, tools, or lighting. A subpanel provides the capacity to add these circuits without overloading the existing wiring or requiring extensive modifications to the main electrical panel. Thirdly, a subpanel facilitates compliance with the NEC. The NEC outlines specific requirements for the installation and wiring of subpanels, including grounding, bonding, and overcurrent protection. By installing a subpanel, the electrical system in the garage can be brought into compliance with these regulations, ensuring safety and preventing potential hazards. The size of the subpanel required will depend on the total electrical load of the circuits it will serve. It is important to calculate the amperage requirements of all appliances, tools, and lighting that will be connected to the subpanel to determine the appropriate size. It is always recommended to consult with a qualified electrician to ensure that the subpanel is properly sized and installed in accordance with the NEC and local electrical codes. Grounding and bonding are critical aspects of subpanel installation. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and energize the circuit. Bonding connects all metallic parts of the electrical system together, creating a low impedance path for fault current. Improper grounding and bonding can create a shock hazard and increase the risk of electrical fires. When installing a subpanel, it is important to use the correct size and type of wiring. The wiring must be rated for the amperage of the circuit it will serve, and it must be suitable for the environment in which it will be installed. For example, in damp or wet locations, weatherproof wiring must be used. Overcurrent protection is another essential aspect of subpanel installation. Circuit breakers or fuses are used to protect the wiring from overloads and short circuits. The size of the circuit breaker or fuse must be matched to the amperage of the circuit it will serve. Using an oversized circuit breaker or fuse can allow the wiring to overheat and potentially cause a fire. The NEC provides detailed guidelines for the installation and wiring of subpanels. These guidelines cover topics such as the location of the subpanel, the size and type of wiring to use, grounding and bonding requirements, and overcurrent protection. It is important to follow these guidelines carefully to ensure that the subpanel is installed safely and correctly. In summary, if there are more than 2 circuits running to the garage, installing a subpanel is generally required by the NEC to provide individual circuit protection, facilitate circuit management and expansion, and ensure compliance with electrical codes. Consulting with a qualified electrician is highly recommended to ensure that the subpanel is properly sized, installed, and wired in accordance with the NEC and local regulations. Ignoring these requirements can lead to safety hazards, electrical fires, and potential code violations. Therefore, it is crucial to prioritize safety and compliance when dealing with electrical installations in garages. When determining if a subpanel is needed, it's important to consider the existing electrical setup in the garage. If the garage is already wired with a single circuit for lighting and another for a general purpose outlet, and there are plans to add more electrical devices or equipment, then a subpanel becomes necessary. For instance, If the homeowner intends to install a workshop with power tools, a dedicated circuit for each tool would be required to prevent overloading the existing circuits. In such cases, a subpanel provides the additional capacity to accommodate these new circuits safely. Furthermore, consider the type of equipment being used in the garage. High-power tools like welders, air compressors, or electric vehicle chargers require dedicated circuits with higher amperage ratings. These types of equipment cannot be safely connected to a general-purpose outlet, as they can easily overload the circuit and trip the breaker. A subpanel allows for the installation of these dedicated circuits, ensuring that the equipment operates safely and reliably. Another important factor to consider is the distance between the main electrical panel and the garage. If the garage is located a significant distance from the main panel, voltage drop can become an issue. Voltage drop occurs when the voltage at the end of a long circuit run is lower than the voltage at the source. This can cause appliances and equipment to operate inefficiently or even fail to function properly. Installing a subpanel in the garage can help to mitigate voltage drop by providing a closer source of power to the electrical devices in the garage. The subpanel is fed by a larger gauge wire from the main panel, which reduces the voltage drop over the long distance. In addition to the technical aspects, it's also important to consider the practical benefits of installing a subpanel. Firstly, a subpanel makes it easier to troubleshoot electrical problems in the garage. If a circuit breaker trips in the subpanel, it's easy to identify the affected circuit and determine the cause of the problem. This can save time and money compared to having to trace the circuit back to the main panel. Secondly, a subpanel provides a convenient location to add new circuits in the future. As the needs of the garage change, it's easy to add new circuits to the subpanel without having to run new wires all the way back to the main panel. This makes it easier to adapt the electrical system in the garage to changing requirements. Thirdly, a subpanel can increase the value of the property. A well-wired garage with a subpanel is a desirable feature for many home buyers. It provides the flexibility to use the garage for a variety of purposes, such as a workshop, a home office, or a storage space. This can make the property more attractive to potential buyers and increase its market value. When planning the installation of a subpanel, it's important to consider the location of the subpanel. The subpanel should be located in a dry, accessible location that is protected from physical damage. It should also be located close to the area where the electrical devices will be used. This will minimize the length of the circuit runs and reduce the risk of voltage drop. The height of the subpanel is also important to consider. The NEC requires that the top of the subpanel be no more than 6 feet 7 inches above the floor. This ensures that the circuit breakers are easily accessible for operation and maintenance. The subpanel must also be properly labeled. Each circuit breaker must be labeled with the circuit it serves. This makes it easier to identify the correct circuit when troubleshooting electrical problems. The labeling should be clear and easy to read, and it should be updated whenever changes are made to the electrical system. The NEC also requires that the subpanel be properly grounded and bonded. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and to energize the circuit. Bonding connects all metallic parts of the electrical system together, creating a low impedance path for fault current. Improper grounding and bonding can create a shock hazard and increase the risk of electrical fires. Therefore, it's crucial to follow the NEC guidelines for grounding and bonding when installing a subpanel. Firstly, the subpanel enclosure must be grounded to the grounding electrode system. This is typically done by connecting a grounding electrode conductor from the subpanel enclosure to a grounding rod or a metal water pipe. Secondly, all metallic parts of the electrical system, such as conduit, junction boxes, and equipment enclosures, must be bonded together. This is typically done by connecting a bonding jumper from each metallic part to the grounding busbar in the subpanel. Finally, the neutral conductor must be isolated from the grounding conductor in the subpanel. This is done by using a separate neutral busbar and a separate grounding busbar. The neutral conductor should only be connected to the neutral busbar, and the grounding conductor should only be connected to the grounding busbar. This prevents neutral current from flowing through the grounding system, which can create a shock hazard. In addition to the NEC requirements, local electrical codes may also have specific requirements for the installation of subpanels. It's important to check with the local electrical inspector to determine the specific requirements in the area. The local electrical inspector can also provide guidance on the proper installation techniques and materials to use. When installing a subpanel, it's important to use high-quality materials and equipment. This will ensure that the subpanel is reliable and safe to use. Use only UL-listed circuit breakers, wiring, and other components. UL-listed components have been tested and certified by underwriters' laboratories to meet safety standards. Also, it's important to use the correct size and type of wiring for the subpanel. The wiring must be rated for the amperage of the circuit it will serve, and it must be suitable for the environment in which it will be installed. For example, in damp or wet locations, weatherproof wiring must be used. When connecting the wiring to the circuit breakers and other components in the subpanel, be sure to use the proper torque specifications. Over-tightening or under-tightening the connections can cause them to loosen over time, which can lead to electrical problems. Use a torque wrench to ensure that the connections are properly tightened. After the subpanel is installed, it's important to test it to ensure that it's working properly. Firstly, test the grounding and bonding system to ensure that it's providing a low impedance path for fault current. Secondly, test the circuit breakers to ensure that they're tripping properly when overloaded. Thirdly, test the voltage at each circuit to ensure that it's within the acceptable range. If any problems are found, correct them before using the subpanel. The National Electrical Code, specifically Article 225.30, limits the number of supplies to a single building or structure. This means that the detached garage typically is only allowed one feeder supplying it. However, an exception exists in 225.30b that allows for additional feeders for specific purposes or installations. Firstly, for fire pumps. Secondly, for standby systems. Thirdly, for electric vehicle charging systems. Fourthly, for systems with renewable energy sources. These exceptions might allow for additional circuits or feeders, but the general rule is to use a subpanel to distribute power within the garage from a single feeder. Another aspect to consider is the working space around the electrical panel. The NEC, in section 110.26, specifies minimum working clearances around electrical equipment, including subpanels. These clearances are designed to provide sufficient space for electricians to safely work on the equipment while it is energized. The depth of the working space depends on the voltage of the equipment and the presence of any exposed live parts on the opposite side of the working space. The width of the working space must be at least 30 inches, or the width of the equipment, whichever is greater. The height of the working space must be at least 6 feet 6 inches, or the height of the equipment, whichever is greater. The working space must be kept clear of obstructions, such as storage boxes, tools, and equipment. This ensures that electricians have enough room to maneuver and work safely. The NEC also requires that the working space be adequately illuminated. This allows electricians to see the equipment clearly and avoid accidental contact with live parts. The lighting must be sufficient to provide adequate illumination for the tasks being performed. The NEC also addresses the issue of arc flash hazards. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. An arc flash can generate extremely high temperatures and pressures, which can cause severe burns, injuries, and even death. To protect electricians from arc flash hazards, the NEC requires that a hazard assessment be performed to determine the potential for arc flash. Based on the results of the hazard assessment, appropriate personal protective equipment, or PPE, must be used. PPE can include items such as arc-rated clothing, gloves, face shields, and helmets. The NEC also requires that electrical equipment be properly labeled to warn electricians of the potential for arc flash hazards. The labels must indicate the arc flash boundary, the incident energy level, and the required PPE. In conclusion, the decision of whether or not to install a subpanel in the garage depends on several factors, including the number of circuits, the electrical load, the distance from the main panel, and the requirements of the NEC and local electrical codes. While it may seem like a simple task, electrical work can be dangerous and should only be performed by qualified individuals who are familiar with the relevant codes and safety practices. If there is any doubt about whether or not a subpanel is needed, consult with a licensed electrician to determine the best course of action. Remember that safety should always be the top priority when working with electricity. Take the necessary precautions to protect yourself and others from electrical hazards. By following the NEC guidelines and using common sense, it can safely provide electrical power to a garage and enjoy the benefits of a well-wired and functional workspace. The key takeaways are: firstly, adhere to the NEC guidelines for electrical installations. Secondly, prioritize safety when working with electricity. Thirdly, consult with a qualified electrician if unsure about any aspect of the installation. And fourthly, ensure proper grounding, bonding, and overcurrent protection for the subpanel.